Okay, let's look at this problem here. We're given this problem statement. So we have an averaging amplifier is a summer, so that's the key word, that provides an output equal to the average of the inputs. Okay. By using the proper input and feedback resistance resistor values, one can get this output here. Minus V out equals 1/4 times V1, V2, V3, and V4. Additionally, we're given in the problem statement, using a feedback resistor of 10 kilo ohms, design an averaging amplifier with 4 inputs. Okay, so based on the knowledge given to us, information given to us, we're going to have 4 inputs, and we know that by looking at the equation here. We have V1, V2, V3, and V4, so we know we're going to have 4 inputs here. But before we move on and solve this problem, it's always good to write down the equations. So for the summing amplifier, we know for the summing amplifier that V output has to equal minus, and then we do the feedback resistance, RF over our initial, so we have 4 inputs. It's going to be R1 times V1 plus RF over R2 times V2 plus RF over R3 times V3, and finally our last input, which is our V4, RF over R4 times V4. Okay, so all that should equal V output. So now we can compare this equation here to the equation we're trying to come up with, and you see it's very similar. One thing we know is that we're given a restraint or a parameter here, is that our feedback resistance has to be 10 kilo ohms. So meaning our RF has to be 10k ohms. So if our RF is 10k and all of these here, 10, 10, 10, and 10, technically what we're doing is we're saying, well, 10 over R1, R2, R3, and R4 individually, if we factor this out, if we factor all of these values, factor it out, we factor these out, then our output should be 1/4. That ratio should be 1/4. So we know that 10. So just by visually inspecting it, I can say, well, if I need 1/4, I can just take 10/40. That's going to give me my 1/4. So that means my R1 can be 40, which is also going to be equal to my R2, R3, and R4. So we can design our op-amp or averaging op-amp to have inputs of 40 kilo ohms for all of them to get that. Okay. Another way of looking at this, we can say, well, okay, I have my feedback resistor over our input equals 1/4, and then we just rearrange this equation. We say our input is equal to 4 times RF, and that also will give us our 40 kilo ohms. Okay, so one way of doing it is visually inspecting it. Another way is actually computing it. So those are 2 different approaches to doing that. So now that we have that, we can actually draw the averaging amplifier that we're told to design. So I'm going to just scroll up here, and note that this negative sign here will just move out here, and then we pretty much come up with what is given or what is required. So let's go ahead and design this op-amp. So it's a summing amplifier, so meaning we're going to have 4 inputs. So V1, V2, V3, and V4. All of them are going to be connected to a resistance. Okay. All these resistances are going to come into the inverting input of our op amp. Minus plus. This guy is going to be grounded. And this is going to be our V output. Our feedback resistance is given. That's 10 kilo ohms. And then our R1, R2, R3, and R4 are all of them are going to be 40 kilo ohms, as we've determined above. Of course, you can think of other potential values or ratios where you can come up with that same 1/4 equation there. So let's go ahead and just highlight this, and this is going to be the op amp that we're going to design to come up with this equation, or our averaging amplifier, which is simply a summing amplifier.